Hi, in this video we are going to talk about the Bayesian classifier, so let's get started. This is a very efficient supervised learning method. We are going to have labels on the data and we are going to denote it with colors, and we want to decide that we have a training data, and according to these training data, a new sample, we have to classify that new sample. And it works fine even in higher dimensions, so that's why we said that it scales well, and it is able to compete with much more complex support vector machine or random forest techniques. And the most important feature of Bayesian classifiers is that it is able to make good predictions even when the training data is very small. So we have a small training data, and according to this classifier we are able to make very good predictions even in higher dimensions. And why is it good? Because for example, as far as linear regression is concerned, we are not able to use linear regression in higher dimensions. So that's why these kinds of techniques, such as the support vector machine and Bayesian classifier, is very good. But while support vector machine is very hard to implement and to understand, on the other hand, these Bayesian classifier is quite easy to comprehend. So in the next we are going to illustrate it with a little sample. So we have a training data like this. We have 9 yellow dots and we have 11 green dots, and we are going to get a sample and we want to decide whether its color is going to be yellow or it is going to be green. So which cluster does this sample belongs to? And to be able to answer that question with the help of Bayesian classifier, we have to calculate something that's called the prior probability. And the prior probability is just the orthodox probability. We calculate that how many dots are here in total, and we calculate that the fractions, the relative frequency of the yellow and the green dots. And as we can see, there are 9 yellow dots, and that's why the probability of yellow is equal to 9 divided by 20. 9 is the number of yellow dots, and 20 is the total number of dots in our training data. So this is what's called the prior probability. The prior probability of green is equal to 11 divided by 20. Why? Because there are 11 green dots in our training set, and we have to divide it by the total number of dots. Whatever it's yellow or it's green, we just calculate how many dots are in the training data, and of course we don't have to calculate the sample. That's why it's the prior probability. The next step is that we take a circle with a given radius and we calculate how many green dots and how many yellow dots are inside this circle in the neighborhood of the sample. And we calculate this p prime probability, which is something like what's the probability that in this circle the sample is green, and the probability is 3 times 3 divided by 11. 3 is the number of green dots inside the circle. It's very important that we have to calculate just inside the circle, and we have to divide it with the number of the green dots, and because we have 11 green dots, that's why we divide it by 11. The pre-prime, as far as the yellow are concerned, it's something like what's the probability that this sample is yellow. It's going to be 1 divided by 9. 1 because there is only a single yellow dot inside the circle, and we have to divide it by 9 because there are 9 yellow dots in our training set. And with the help of these probabilities, we can calculate what's called a posterior probability, which is going to be the multiplication of these two probabilities. So if we want to calculate that what's the probability, the posterior probability that our sample is green, we have to multiply the probability of green with the probability, the pre-prime probability, which is going to be 33 divided by 220. We have to calculate it for the yellow dots, of course, and it's going to be 1 divided by 20. And we come to the conclusion that the posterior probability for green is greater than the probability for yellow. So that's why we come to the conclusion that as far as this Bayesian classifier is concerned, we can assume that the sample is green because it has a higher probability, and that's why we replace our sample with a green dot. So this is the basics of Bayesian classifier, and if you are interested in the concrete mathematical background, I highly suggest you the article on Wikipedia. It's a very, very interesting topic. As far as I am concerned, I'm interested in these low-level mathematical stuff, but I'm not sure that you are interested in too. You just have to calculate. It is the so-called abstractly modified version of that we have been familiar with. We just have to calculate these probabilities, and we come to the conclusion that we can use the assumption that the features are independent from each other, and we come to the conclusion that it's going to be the equation we are looking for. And this is the Gaussian naive Bayes algorithm relies heavily on the Gaussian bell-shaped probability density function, and we can make our prediction. We can make, as far as you remember, we calculate this circle. We are not anymore rely on this circle. We just calculate it with the help of the Gaussian probability function, and it's going to get us the right answer. And if you want to calculate it with a given example, there's a very, very good example here. You can get a good grasp of how it works and what you have to calculate in order to make that prediction. You just have to calculate the mean and the variance, because the Gaussian probability density function has to know about the mean and the variance to be able to guess. And of course, we have to calculate it posterior and prior probabilities, as we have talked earlier. And whenever the posterior probability is the greater, that's what's going to be our prediction. So that's all about the naive Bayesian classifier. Thanks for watching.